Algebra 1, Section 2-3, solving multi-step equations. Here's an example of a multi-step equation. 11x minus 4 equals 29. And here's another example. 2a minus 6 equals 4. So what we're going to do here is I want x by itself, and I've got to solve this puzzle of what I do to one side, I do to the other side of the equal sign, and I want to get x by itself. So now I'm going to need to divide by 11 to get this x by itself, but it's going to be way easier for me to do that if I get this 4 out of here first. So I'm going to add 4 to both sides. So now I have 11x, negative 4, positive 4 is 0. So I've got 11x all by itself on this side. 4 plus 29 is 33. Now it's much easier for me to divide each side by 11, and I get x equals 3. Now I can check that. 11 times 3 is 33. 33 minus 4 is 29. I've checked my answer. It looks good. Now I'm going to do this next one. Again, I want a by itself, but I want to get this 6 out of here first, this negative 6. So I'm going to add 6 to both sides. 2a equals 4 plus 6, which is 10. And since this is 0, I can just ignore it. Now I divide by 2 so that I have 1a instead of 2a. a equals 5. Now I'm going to plug this back in here. 2 times 5 is 10. Minus 6 is 4. So a equals 5. Looks good. Now, let's do one that's a little bit more tricky here, and then I'll give you some U-tries to do. So here's one that's a little tricky. X minus 5 over 3 equals 2. Oof, rough. Okay, I've got 3 in the denominator here. So what this can look like is really 1/3 times x minus 5 equals 2. This statement here is the same as this statement here. If this is helpful, then you multiply by the reciprocal, which the reciprocal of 1/3 is 3. So I multiply this by 3, and I multiply this by 3. What I do to one side, I do to the other, and then I will have x minus 5 by itself. Another way I can do this is say, I know that 3 is in the denominator, and so if I multiply this by 3, then I have a numerator of 3, and so this will become 1. So 3 divided by 3 is 1. So I end up with 1 x minus 5 equals 2 times 3, which is 6. Then I add 5 to both sides. X equals 11. Now we can check that. 11 minus 5 is 6. 6 divided by 3 is 2. 2 equals 2. So I've checked my work. That looks good. Now let's do some U-tries. 3 over 2a minus 8 equals 11. We're going to do this one, and then I'm going to have I'm going to have 4 altogether. C plus 1 over 3 over negative 3 equals negative 21. C 8 equals x minus 5 over 7, and D y over 5 minus 6 equals 9. All right. Get to work on these two, and then we'll go over them together. Pause and get to work now. Okay, let's do this first one here, A. I'm not going to look at this yet. I just want to get this 8 out of here. So I'm going to add 8 to both sides because it's negative, so I'm going to want this to be 0. 3 halves A equals 11 plus 8 is 19. Now I'm going to multiply this by 2 over 3. I need to multiply by the reciprocal, 2 over 3. And I end up with, this is 1a, equals 19 over 1 times 2 over 3. 2 times 19 is 38 over 3. Kind of gross, but that's the way it is. If I plug this back in here, I'm going to end up with 11. Yep. So this is a yucky one, but that's just the way it is sometimes. So 38 over 3, so if I were to plug this back in, 3 and 3 cancel out. 38 divided by 2 is 19. 19 minus 8 is 11. All right, B. So I'm going to multiply this one by 3 over 1, or negative 3 over 1. Multiply this side by negative 3 over 1. What I do to one side, I do to the other. So I end up with C plus 1 equals negative 3 times 21, which is positive 63. Subtract 1 from both sides. C equals 62. I'll go back and check that. We're right. Now, for this one, C, I want to multiply both sides by 7, or 7 over 1, to get that 7 out of there. And so I've got 56 equals x minus 5, because 7 divided by 7 is 1. Add 5 to both sides. I get 61 equals x, or x equals 61. And D here, I'm going to add 6 to both sides. Y over 5 equals 9 plus 5, which is 15. Then I want to multiply both sides by 5. Y equals 15 times 5, which is 75. If I plug that back in here, I will see 75 divided by 5 is 15. 15 minus 6 is 9. So I've checked my work, and that is it for 2-3.